Okay, please get your pens and notebook ready for the lesson. Alright? Okay, so in this video, we are going to talk more about geometric sequences. Okay, in the previous video, we have learned how to use explicit rule for the geometric sequence. And we have done some simple familiar examples. In this video, we are going to have a deeper understanding of geometric sequences, so there will be some more difficult questions. Okay, first, we need to know how to find n in a geometric sequence. What do we mean by n? Okay, n here means the number of terms in a geometric sequence. Alright, so for example, in our previous video, we have learned that for a geometric sequences, the explicit rule is Tn equals T1, that means the first term, times R to the power n minus 1. Okay, in the last video, we have learned how to find R, and we can, by finding R, we could find a particular term, right? But this time, if we give you the Tn, can we find out which term it is? Okay, that means the number of terms in the sequence. Alright, so that would be the subject for our first example, right? Okay, let's see our first example. Consider geometric sequences 5, 10a. Find the value of a. Alright, so let's think, because this is a geometric sequences, okay? So essentially, we should know that from 5 to 10 and 10 to a, they have the same common ratio. Alright, so our 5 will be our first term, right? And 10 will be our second term. A will be a third term. Okay, so let's think how to find A. So how to find our third term? First, if we use the first two terms, you could find the common ratio, and so that's the common ratio. Alright, and for that common ratio, we use second term divided by first term, not the other way around. 10 divided by 5, so that's common ratio is 2. So how could we find R? Okay, so R is T3, right? So let's say if we got R and we are going to find T3, to find T3 we use that explicit rule, T1 times R to the power number of terms minus 1. Okay, right, so that means T1 now is 5 and R is 2. 3 minus 1 is 2 again, so that's 20. Okay, so that's T3. Okay, and B is more interesting. Find the value for R such that rth term of the sequence is 320. Okay, so it's about rth term. Okay, so you need to find that R. Okay, so let's write the equation again. Okay, so it's a bit confusing, right? Because we have used that R as a common ratio, but now there's another R. Okay, so to avoid confusion at this stage, may I change the question a little bit? Okay, so let's change this R into K for better understanding, because I don't want you to deal with too many unfamiliar terms at the same time. So let's find the kth term. Okay, so what's K? Right, okay, let's say if I'm going to find kth term, I'm going to use this explicit rule again. Alright? Okay, so what's TK? TK should be 320. That's a given. T1, of course, we know that is 5. R is 2. K minus 1. Okay, so when we divide, of course, can we multiply? That's 5 to 10, 2. Some of you might do things like this. Alright, then you should know this is wrong. Okay, because we should know that 2 is under the power of k minus 1. So 2 is not 3. 2 is not 3 to multiply, that's 5. Okay? It's not available to multiply, that's 5. You have to do the power first and then do the multiplication of 5. Okay? So that basically we can't multiply that's 5 with 2 at this stage. But we can divide that's 5. We can divide that's 320 by 5 on the other hand by solving equation. Okay, so that will give you 64, isn't it? Alright, okay, so for 64, and that's 2 to power something, how can we find, how could we find the power? Okay, there are different ways to do it, right? But for us, let's think 64 as a power of 2. We all know that for the power of 2, there are number of it should be quite familiar for some of you, right? Okay, for the power of 2, we know that's 2 to the power 1 is 2, 2 to the power 2 is 4, etc. If you track that, you should know that 64 actually is 2 to the power 6. You can use your calculator to check. Alright? Okay. 2 to the power 6 equals 2 to the power k minus 1, right? Okay, so how could we find that's k? Because both of them are under the same base, alright? Okay, the base are the same, so you could compare their exponents. Okay, that means 6 must equal k minus 1, okay? So k equals 7. So we've done it, alright? Okay. Don't be so concerned about that 2 to the power 6 thing. You could use a calculator at this stage, but over the time, you should know that some very common powers of 2 and 3 and 5. Okay, possibly you need to know them. Alright, okay. So that's a chapter we call exponential functions. At that time, we possibly will get more familiar with 2 to the power or 3 to the power, things like this. Alright, okay, so that's pretty much our first example, right? Okay, if you don't have any problem, okay, so let's move to our second question. Okay, so it's similar but not the same, right? Okay, again they give you a geometric sequence. This sequence is an alternating one because positive, negative, and the common ratio is of course negative. Find the general term Tn of the sequence. Okay, so how to find general term? Last time we've learned it. Okay, last time we've learned how to find the general term. Okay, if you want to spend some time to work on this, you might pause the video, try to do it by yourself, and then track the answer. You can always pause your video or rewind if you are not quite sure of something, or you want to just do it by yourself first. Okay? Right, so let's say if we are going to build up an explicit rule for Tn, what do we need? We need R, right? So R would be T2 over T1, if you remember that. Okay, so it must be negative number, negative 3. Okay, and Tn would be T1 times R n minus 1. So that's the explicit rule. Okay, so that's the general term. That means you need to write that explicit rule, like 5 times minus 3 and minus 1. Okay, something is missing. I give you 5 seconds. What I'm missing here. Okay, 5, 4, 3, 2, 1. Okay, anyone get it? Yes, that's, you need to get at that bracket because that's a negative number. You can't just write it without bracket and to the power. Okay, so that would be our general term. Okay, if the kth term of the sequence is minus 135, find the value of k. Okay. 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 So, sorry, possibly I should write that more properly. So that's kth term, right? Tk equals T1 times R2 minus n minus 1. Okay? Okay, it's time for you. Alright, oh, something wrong. Okay, that should be k minus 1. Okay, it's time for you to plug in the numbers to find k. Okay, you might need to pause the video now and try to do it by yourself first and track the answer, right? Okay, you could do it like I think that's 2 minutes will be good enough. Alright. Okay. Okay, if you haven't finished, you can pause the video and try to spend more time on it. Okay, I'm just going to continue here now. Okay, so tk is minus 135, the first term 5. Okay, just like the previous term, but you change that n into k, right? Okay, let's say minus 135 divided by 5, right? Okay, and all right. Okay, it's minus 3. Okay, think about the minus 3 power. What minus 3 power can give you minus 27? Okay, you might think like, okay, if that's minus 3, that's square should be 9, right? Minus 3 to power 3, that means 9 times minus 3 minus 27. Okay, so that would be the answer, right? So it should be minus 3 times 3. Okay, equals minus 3k minus 1. Okay, so you see for the question we give you in this chapter, you can write that number like minus 27 using the same base as numbers on the other side, right? So you can always express the number using the same base. If the base is minus 3, then the number you are using must be able to be expressed in terms of minus 3 to power something. Okay, so now we could compare their powers. Okay, so that 3 equals k minus 1, k equals 4. That's it. Okay. All right. Okay, so for these questions, for this type of questions, they are not going to be complex familiar. Possibly they are still simple familiar because it's not that much skill you need to know how to find the power, the unknown power. All right. Okay, especially when they give you the number which can be expressed using the same base. All right. Okay, let's move on. All right. Okay, so that will be our second example, which will be more difficult then this time we call it complex familiar. Alright. For the first one, find the number of terms in the geometry sequence. 2, 10, 50, 250, which is smaller than, okay, number of turns. Find the number of turns, okay, such that it's still smaller than 5,000, okay. Still smaller than 5,000. How could we do this? Alright, so we're going to use the same technique, but possibly we need to use a bit different presentation. Okay, so let's try to do it in this way. Again, we know that the first term is 2. R would be second term divided by first term. It should be 5. Okay, so our Tn would be, okay, it should be T1 times R n minus 1. Okay, so that would be 2 times, okay, 5 to, okay. So now, seems we know that the number of terms, we don't know which term, but it must be smaller than 5,000. So you need to know the biggest term because R is greater than 1, of course, right? So that means in this sequence, number becomes bigger and bigger, but we don't know when, for which term, that term would be close to 5,000. Okay, so you need to find the greatest term which is less than 5,000. We don't know which one is, so let's write the thing like this: 2 times 5 n minus 1, that's Tn. We need that number less than 5,000. That makes sense? Okay, we need that less than 5,000. So how could we solve it? Okay, it's going to be difficult, right? So first, let's try to move some numbers to the other side. Okay, for example, that's 2, and so possibly we just move that 2 to the other side because you divide 2 by both sides, so the inequality is not going to be changed. Okay, up to now it's really difficult because can we write 2,500 into the power 5? 25, of course we can write as 5 square, but how about another 20? We don't know. Alright, so that's a way that we can do it. Possibly this will be in paper 2 question, it won't be in paper 1. Okay, remember this one should be in paper 2. That means you can use your calculator, otherwise it will be really difficult. Okay, so let's use our calculator to see how could we find which term it is. Okay, sorry. Okay, so if you use your calculator, there are few ways you can do it. Okay, so one way would be much easier if you just try to put different numbers into n to see what number it is. Okay, for example, I'm going to use 5, okay, to the power, okay, like now, if I use, how about 7 minus 1, okay, so, whoa, this number is much greater. Okay, remember that we need a number which is less than 2,500, but this number is much greater than that. Okay, so that means n is too big for it. Okay, so let's copy it. And let's move on to here. But this time I'm going to use much smaller number and 4. How about that? Yep. Okay, so it becomes much smaller. Okay, you need something which is closer to that 5,000, right? Okay, let's do it again. So how about we do it like 6? Yeah, so that would do it. Why? Because you know, if you put n equal to 7, it's much greater than 5,000. But if you put n equal to 6, it's less than 5,000. So that n would be 6, right? Okay? Alright, okay, so okay. So we know when n equal to 6, 5, 6 minus 1 is, alright, 1, 5, 6, 2, 5. But when n equals 5, that's this one, alright. Okay, so that means n equals 5 will be the answer. So that should be only 5 terms in this case, right? Am I correct? Oh, sorry. Sorry. Something wrong. Okay, because I need something smaller than 2500. It's not 5,000. Sorry, I'm making a silly mistake. So I need to carry on that. Okay. Okay, so let's do another one. So that's 6. About 4. Okay, so we know that's 5. When n equals 5 is 625. It's less than 2,500. Okay. Right. Okay. Let's go back here. All right. So when n equals to n equals 5. Something wrong, isn't it? I think I got. Oh, sorry. Is the problem with switching my screen really annoying. Okay. Yeah, I remember 5 should be the answer, but somehow I got it wrong. Yeah, so sorry about this. Possibly I should capture that screen right away. Okay, so let's make it more clear. Okay, so when n equal to 7 is much greater than 2,500, we need to make sure this inequality is satisfied. Okay, so when n equals 7, of course, it doesn't satisfy this. Okay, when n equals 6, okay, it doesn't satisfy. When n equals to 5, it satisfies. And also, it's the biggest number because when n equals 6, it doesn't satisfy, right? Okay, so our answer would be n equals 5 is the answer. So that means that should be 5 terms, all right? Okay, okay. Good. All right, so let's move on to our second question. This time, this one is a bit different than the one we've just done, right? So this time they give you a geometric sequence, but this sequence becomes less and less. Okay, find the least value for m such that m terms less than 60. Okay, so you need something less than 60. All right. Okay, so as we can see, the terms getting less. All right. So how could we do it? You are going to use the same method. Okay, so again, you might pause the video now and you might restudy our previous example and spend some time to do it by yourself and track the answer after that. Okay, I'm going to pause the video for a little moment. Okay, uh, let's continue. Alright, so I've got R equals 3/4. Okay, because that's 600 divided by 800, that's 0.75, and Tn equals T1 times R to the power n minus 1. Okay, so that's R should be 0.75 to the power n minus 1, right? Okay, so again, so we need that term to be less than 60. Alright, so that means you need to this number less than 60. Alright, alright. So what number do you get? 60. Okay, again, we need to use our calculator to track which number will give you. You need to find the biggest number m such that this number is still less than it's less than 0.075. Okay, so let's try to use our calculator. Okay, so to start with, let's see if I use 7 minus 1. Okay, so let's go back to see. So need a number m such that m minus 1 to the power of 0.0275 less than 0.075. But now this number is 0.1, so that's bigger than the number we want. Okay, so that's possibly will be 2. Okay, so because we know that the term in the sequence become smaller and smaller in this time. Sorry, can't copy this. Okay, so let's say this time we're going to use another one. Possibly let's try 9. Okay, it becomes smaller, but still greater than 0.015, right? Okay. Okay, it's this time. Okay, so I think that will be the case because this one is bigger than 0.015, but it's really close. So next one we'll make it 11 then. Okay, so when n equals to 11, so the number now is less than 0.0275. Okay, so let's say when n equals 10. Okay, we know that's this one. So m, shall we say? Okay, but this one is not less than 0.075. Okay. So that number is 0.05613. So m equals 11 is the answer. Okay. Right. Okay. So this will be the type of question you might see in paper 2 and complex familiar, right? Or possibly complex unfamiliar. I'm not quite sure about this. Okay, but the main technique is that you need to come up with some numbers which can satisfy the inequality Okay, so there are some algebra skills for inequalities, and also you need to substitute numbers, integers into that power, okay, to find the number which can solve the inequality. Then that number will be the answer, right? Okay, and let's move on to see our next type of the question. Okay, so if you still remember in our arithmetic sequence, all right, so still remember that. Let's have a bit of revision. In AS arithmetic sequence, at the beginning we learn one particular formula for Tn starting from T1. So that's arithmetic sequence, because our arithmetic sequence, they have a common difference. Okay, but then we learned that if the question doesn't give us T1, it gives us like one particular term or two particular terms in the sequence. For example, they might give you T3 and T6, or T5 and T11. Okay, so do we have formula for that kind of situation when it's not starting from first term? Okay, and so that's a generalized version, generalized explicit rule, and that's generalized explicit rule is like this: Tn, when we start from Tm, all you need to do is add n minus m common difference, all right, instead of n minus 1 common difference. You add n minus m common differences, and you will get the answers right away. Okay, so remember that m must less than n. Okay, so that's for our arithmetic sequence. So how about for GS? Do we still have some kind of corresponding generalized explicit rule? And the answer is yes. Okay, let's say if we have GS, we know that is in the form of the first term. Suppose the first term is T1, and our second term will be T1 times R, so that's our second term, right? And our third term to T1 times, okay, 2R, right? And so on, okay. And for our T, for example, our T2, T1, R4, that's our T. Oh, sorry, something wrong, isn't it? Okay. Sorry, that T3 is R. Yep, T4. Okay, suppose we have one term like T 15, then should be T1 times R to power of 14, right? Okay, so let's see, that's all these terms are in terms of T1, right? But if we want to express T4 in terms of T2, what could we do? Okay, actually all you need to do is from T2, you multiply how many R, okay, multiply 2R, because what? Because from T2 to T3 you need to multiply R, T3 to T4 you need to multiply another R, okay, so T2 times R square will give you T4, okay. And if we want to do something like from T2 to T15, so how many R do you need to multiply? Let's think about this. From T1 to T15 you need to multiply 14 R, right? Okay, but if you start from T2, how many R you need to multiply? You don't need to multiply 14 R. All you need to do is to multiply 13. Okay, how could we get that 13? It's by 15 take 2, right? So likewise, if I'm going to do T4 to T15, all I need to do is T4 times R to the power. Okay, I give you 5 seconds. Okay, 5, 4, 3, 2, 1. If you really understand this, you should multiply 11. How could we get that's 11? It's from 15 minus 4. Okay, so that's why we are going to introduce you very similar rule for GS, which is generalized explicit rule. Okay, so for the generalized explicit rule, we will have this formula Tn. If you start from Tm, and that's m less than n, all you need to do is multiply r to the power n minus m. Okay, right? Remember that we have m less than n. Okay, so that's why when you use that formula, that explains why T15, if you start from T4, will give you 15 minus 4, that's 11. Right? So from T4 to T15, all you need to do is multiply by 11 common differences. Alright? Okay. Is that okay? If you need some time to digest the idea, you might pause the video to think about this. This is quite important for our coming examples. Alright? Okay. Okay, so let's try to apply what we have learned to this example. For geometric sequence with general term Tn, the third term and the fourth term are 12 and 36 respectively. Could we find the common ratio? Of course we can. Okay, so how could we find the common ratio? Okay, it's from 3 to 4, right? Okay, so we could apply the above rule. This time we think, okay, Tn equals okay, so let's say our n is 4 because n must be less than n, right? T3, 4 minus 3, okay? So that means T4 is 36 and 12, R power 1. Okay, R should be 3, right? Okay, so that gives us the common ratio. Okay, could we find Tn? Okay, so Tn means you need a explicit rule for that. Alright, so you can't use this rule for the answer because m is unknown. We don't know which is Tm, so you need to go back to the previous explicit rule using the first term. Alright, so you need to find first term. Okay, so now because we know that's T4, T3 is 12. Alright, so because we know T3 is 12 and T3 can be written as T1 times R squared, okay, 3 minus 1 equals 12. Okay, so T1, 3 to the power 2 square T1, 9. Okay, so that's 4 over 3. Okay, so we got T1, you got R, that means Tn can be written as T1 times R to the power n minus 1, right? Okay, so T1 is 4 over 3 times 3 to the power n minus 1, okay? Alright, so you see that 2 3's here, so possibly you might consider move that 3 over here. So that's another simplification. Alright, so that's it. So that's Tn. Alright, alright, so that's how we do it. We have find Tn in terms of n. Okay, so that's the geometric sequence. They give you two terms in the sequence, and they need you to find the common ratio and the explicit rule. All right. Okay. And let's go to see our last example in this video. It's given that second term and sixth term are minus 80 and minus 5. Find the first term. So basically the same thing, and the common ratio, and find the general term of the sequence. All right. Okay. So basically, you are going to use the same method. Okay. You are given second term and also the sixth term. Okay, so that means, can we apply this one again? We use that generalized explicit rule, right? Okay, so that T6, T2, that's R, because we don't know R yet, so we're going to find the common ratio. That's n minus n, yeah, 6 minus 2. Okay, so how about T6? So T6 should be minus 5. T2 should be minus 18. Yep. Okay, so that means of minus 5 from minus 18. Okay, so 1 over 16 equals. Okay, be careful here, right? So if you are going to find R, and that's power, so this power is an even number, okay, then it could be tricky. Because what? Because we know that when the power is even, then that R could be negative, and it turned out to be the power, because the power is even number, even the number R is negative, it could still give you an answer which is positive, right? For example, if we have minus 2 to the power 4 is 16, right? But 2 to the power 4 is also 16. So if I ask you what number to the power 4 equals 16, there are two answers. It could be minus 2 or 2. Okay, so always be careful when that R is, when the power is even number, and you're going to find R, right? Okay, so this type of question would be more difficult. That's why we call complex familiar. All right. Okay, so in this case, let's see how could we do it, right? So because we know that for the power 4, we might think, yes, so that's 1 over 2 power 4, because we know that 2 to the power 4 is 16, right? Equals this, or minus 1 over 2 equals this one as well. Okay, so actually your R could be 1 over 2 or minus 1 over 2. So there are two different answers, right? There are two different answers. Okay, and so, and also that will give us something different, more difficult to find the first term. So we haven't found the first term, right? So we need to continue here. Okay, we need to continue here to find our first term. Okay, so there are two cases when R equals 1/2. All right, so our second term is minus 80, right? So T2 equals 80, and T2 equals T1 times R, 80, right? So that means T1 times 1/2, 80. T1 is 160. But if your R is negative number, then obvious all the thing will be the same, but you will have T1 times minus half equal to 80, and T1 equal minus 160. So there are two different answers for T1, right? As such, in B, you are going to find a general term. There are two different answers for your general term. Okay, like if for R and T1 are both positive, right? And oh, sorry, something wrong, right? So it should be, sorry, I overlooked that minus. Okay, sorry about this. Okay, so that's a small mistake. That's T2 minus 80, so that means, okay, so, okay, let me say again. When R is equal 1/2, T2 equals minus 80, right? And for T2 equals minus 80, you get T1 equals minus 160, right? But if R is 1 minus half, and you use the same formula, but R becomes negative, in this case, T1 is positive. Okay, so that means we have two versions of our general term. The first version, when R equals half and T1 equals minus 160, so it should be like this, right? So, but there are two versions. Okay, so version 1, okay, it should be Tn equals minus 160 times R half and minus 1, okay, and version 2, Tn 160 equals, okay, so this question is quite difficult in terms of you might have different cases. So it's complex familiar or complex unfamiliar. Okay, it could be complex unfamiliar at the end of the day, not quite sure. Okay, and okay, so that's basically our second video on geometric sequences. Okay, so in this video we see some more difficult questions. Okay, you need more algebraic skills to do it, and we also will apply the generalized explicit rule to help us when two particular terms are given in the sequences. Okay, all right, so right now you should be able to do some questions, okay, in our notes. So in the notes I give to you, I copy some question from the textbook, and you can have a look. Okay, and also there are some exercises like 14a. All right, so you could do most of them by now, except possibly for some word problem we are going to cover next time in our geometric application of geometric sequences. All right, so try to do the homework. If you have any question, go to the collaboration area in our OneNotes to post your questions. I'm more than happy to have a discussion there. Okay, see you next time.